Okay, good morning, Pute. Yes. Okay, good morning, all. Yesterday we just discussed about what are the main thing. Okay, that following with we are just taking just not okay. Yes, here at last we are discuss about decomposition programming problem. In decomposition programming problem, like in the real world game, we are talking about snake and ladders game. Okay, so there should be following up some steps. Okay, you should be following some steps in a snake and ladders game. So you can see in this game, you will be going up when you are surpassing what? When you are surpassing a ladder, you can going up. If you bite with the snake, you have to going down. Okay. However, the game should be winning what? Going first place to 100 place here. Like that one, there should be have many paths. Okay, but it should be having only one process. Okay, there should be have only one process, but it can be have many parts with that one. Okay, you should be know about that one. Okay, so you should be know checking if the snake or ladder move in position, checking the place has one like that one. Okay, so here is having another example. The same snake and ladder board game problem could be decomposed in a different way. Here is another way. Okay. So here you can see, you can, if you want, you can decompose like this. You can break, split into the this system. Select the number of players, set players in the best position. Okay. You can what? Display board. You can roll number block. You can move player. Check if they have one. Like that one, if you want, you can break. Okay, they are not having proper way. You can following up any of these methods. Okay, you can following up any of these method. They are not having actual one way. Okay, so did you notice the sum of the sub-problem, like example 1 or 2? For example, sub-problem move player. Okay, so player in the example 2 same as sub-problem move in the place. Okay, so they are having same thing, but it can be go with the different way. Okay, the process is same, but they are having different way to process that one. Okay, like that one, you can see they are having what different scenarios in the sub-problems. Okay, that I wanted to. Okay, actually, why we decompose like this? Okay, earlier we see that solving the large problem is easier if you break down into the solving smaller subproblem. So there are also other reason why we are doing this. Okay, as previously we have said, okay, it's very easier break down into the small subproblems into big subproblem. We can break down into the small decomposition thing. Is very easy to process our solving our subproblem. It is very easy. If you are breaking into the small parts, that one very easy. That one thing. That the main thing is that actually. Okay. Like earlier we see, it is very easy to break into the small problem. So there are also other reasons why we are doing like that. Okay, there maybe have other reasons. What are they? That decomposing problem into small subproblem is more natural for us as a humans. Normally, it's very natural. We are not doing whole thing in at one time. Why? Think about the large task. But example, we have to tidy and clean in the whole home. Okay? If we see like this, look at this house like your room, no? Yes. Like your room. What happens? It is very untidy. But I wanted to clean this one. Do you try to clean whole thing at once? No. So I started with the corner. I arrange a bed first. Okay. I arrange all the clothes second. I arrange all the books. Third, I arrange all the colors. Okay, like that one, you are what? You are split this task into small tasks. Okay, you can what? You can break into the decompositions by this subproblem. Okay, you can break into small parts of the subgroup. That's easy for us. Actually, that's easy to the us. So like that, lot of people tend to the involve writing a computer program. Sometimes it might be hundred of people. Okay, the computer program, that big software or big program, no need to write by alone, no need to write by one person. Normally, you have to what? Divide the task. Actually, it may be involved hundred of people. So these people cannot all work together on the same project at the same time. All of them are not working what? Same project in the same time. If the problem is decomposed into sub-problems, now individual people, that is smaller group of people can work into solving specific sub-problem. Okay. Normally we are dividing our works. Okay? So these people can work independently at same time, and then program can be combined once they are finished. Normally like that. Okay. Normally whole tasks, there are what? Divided into the small task. After that one, they are doing that project. Okay. Here our task. For example, I take here our task. Okay. If they are having 3 members, 4 members, I divided this task into 4. Okay. Here member A, here member B, here member C, and here member D. They are do separately. They are do this project separately. At last, what do you do? Again, it will be combined these 4 projects together, and you can finalize your final project. Clear? Like that one. Normally, people cannot work together on the same time. Okay. So if we are, this is important. If the problem is decomposed into sub-problem, into individual people or group of people can work solving a specific sub-problem. Okay. So these people can work independently at same time. Okay. You can work independently, not work together. Work as a small group or something there. And then programmer can be combined once they are finished. Is that clear? Normally, you have to divide program into small tasks like here. You have to divide program into small tasks like here. After that one, you can combine that one together. After that one, you can combine that one together. Okay, can you write down this underline part? What is the underline part? Write down this underline part. Okay, just as a new paragraph or new star mark, just write down. If the problem is decompose, write down underline part. If the problem is decompose into subproblems, if the problem is decomposed into subproblem, individual people, individual people, or a smaller group of people, if the problem is decomposed into subproblem, that individual people within bracket or a small group of people or a small group of people can work on solving a specific subproblem, can work on solving a specific subproblem, can work on solving a specific subproblem. These people work independently at the same time. Okay, these people can work independently at the same time. Okay, so all of these people can work independently at the same time, and then programs can be combined once they are finished. After that one, that program can be combined. That program firstly splitting, decomposed. After that, right? After finishing each and every task separately, you can combine that one together. Okay, these people work independently at the same time, and then programs can be combined once they are finished. Okay, that program can be combined once they are finished. Okay, write down that. Quickly write. Okay, like that, you can split your program into subprogram. Okay, right there. If the problem is decomposed into subprogram, if the problem is decomposed into subprograms, individual people or a smaller group of people can work only solving specific subproblem. Can work on solving a specific subproblem. So these people can work independently at the same time. And these people can work independently at the same time, separately at the same time. Okay, they can work separately but at the same time. And then program can be combined once they are finished. Okay, after finishing that one, program can be combined. Okay, some programmers specialize in the particular area. Okay, some are specialized in the graphic artificial intelligence, some are graphic design, some are interfaces. Like that one, programmers may be specialized with the specific area. If a program is divided into subprogram, this specialized can work on their areas. Okay, if the program is divided into subprogram, that's important. They can work only their specialized area. When we are divided into subprogram, it's better to specialize area according to their division. They can divide into subprogram. This specialized can work on their specialized area. Okay, if the problem is divided into subprogram, this specialized can work on their specialized area. So actually, what is there? This means the program are likely to better because each person is doing what they are doing. It is good, no? So if they are divided like this means what happened? Program is likely to do better. They are doing their best part. If they are doing well with the specialized area, they can create a good output, no? So because each person doing well what they are doing well. Okay. Write down that part also. Separately write down. Write in a new line. If the problem is divided into sub-problems, if a problem is divided into sub-problems, this is specialized. This is specialized can work on their areas. Can work on their areas. They can be work on their specialized area, their likely area, their familiar area. Because of that, they can give in a good product, good output. So, right there. This means the programs are like to write this underline parts, yes, underline parts, yes, write the underline parts. So this means the programs are likely to, this means the programs are likely to better because each person is doing what they do well. Each person is doing what they do well. Okay. This means the program will like to do better. Because why? Because each person is doing what they do well. Each person can be doing what they do well. So it may be good output. Okay. If the problem is divided into sub problems, these specialized can work on their areas. So this means the programs are likely to better because each person is doing what they are doing well. Okay. So we divide into sub program, specialized areas on each and every person. It's better. Okay. Likely that you can divide. The main thing, they are having a sub problem. Okay. They are having a sub problem. You can divide, split into small parts. It's better to split small parts according to their likelihood, according to their good areas, such that you cannot divide, just not divided. Okay. It is not randomly division. When you are divide, this part is good for this one. Like in the cricket team, some are good playing good in the bowling, some are playing good in the batting, some are playing with the wicket keeping. Because of that, they are having bowlers, they are having batsmen, they are having wicket keepers, like that. Here, you have to divide your specific task into a small tasks with the what? With their prepared best area. Okay. Not only there, we are divide the specific task with the prepared their best areas. Okay. So they are having much more. Okay. So we will discuss the other thing. Okay. What is the decompose mean? How decompose problem? How problems? How? Why do we decompose? Okay. You can do this activity at home. What is question 1.9? You can do this one at as a homework. Okay. You can do now as a homework this question 1.9. Okay. Do this one as a homework question 1.9. Okay. Do it at home. Okay. So page number 159. Yes, you can do that one at home. So I think it's almost time finished for today. Yes. Okay. Do that one at home. Yes. So I hope to wind out the session for today. Okay. So I think you got the idea of decomposition very well. Yesterday also we discussed that one. So today we are thinking with the task. Okay. So we will discuss later on the other days. Okay. So thank you very much for coming. We will discuss other thing next day. Okay. Thank you very much for coming. See you next day. Okay. Good morning, all. Bye. See you.